Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. In the vast theater of space, planets perform an eternal dance across our night sky, occasionally coming together in spectacular displays that have captivated humanity for millennia. Tonight, we witness one of nature's most elegant performances, the conjunction of Venus and Mars, two worlds that couldn't be more different, yet appear to embrace in the cosmic darkness above. A conjunction occurs when two or more celestial objects appear close together in Earth's sky, though they remain separated by millions of miles in actual space. It's an illusion of perspective, much like how distant mountains can appear to touch the horizon when viewed from afar. These events remind us that we're passengers on a moving planet, orbiting through a dynamic solar system where gravitational forces choreograph an intricate celestial ballet. Venus, our nearest planetary neighbor, shines as the brightest object in our night sky after the Moon. This world, often called Earth's twin due to similar size and mass, harbors a hellish environment beneath its reflective cloud cover. Surface temperatures reach 860 degrees Fahrenheit, hot enough to melt lead, while atmospheric pressure crushes down with 90 times the force of Earth's atmosphere. The planet's retrograde rotation means the sun rises in the west and sets in the east, completing one day in 243 Earth days, longer than its 225-day year. Mars, the red planet, presents a stark contrast to Venus's inferno. This rusty world, colored by iron oxide covering its surface, experiences seasons similar to Earth due to its 24-hour and 37-minute day and 25-degree axial tilt. However, Mars orbits much farther from the Sun, creating a frigid environment where temperatures average -80 degrees Fahrenheit. Its thin atmosphere, composed primarily of carbon dioxide, offers little protection from cosmic radiation or meteorite impacts. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. The mechanics behind tonight's conjunction involve the complex orbital dynamics of our solar system. Venus completes its orbit around the Sun in approximately 225 Earth days, while Mars takes 687 days, or nearly 2 Earth years. These different orbital periods mean the planets periodically overtake each other in their celestial race, creating moments when they align from Earth's perspective. The apparent closeness we observe tonight masks the true distances involved. Venus currently sits approximately 25 million miles from Earth, while Mars lies roughly 150 million miles away. Despite this vast separation, gravitational influences between planets do exist, though they're incredibly subtle compared to the Sun's dominant pull. Throughout history, conjunctions have held profound significance for various cultures. Ancient astronomers meticulously tracked these events, using them to develop calendars and navigate both land and sea. The Babylonians, Greeks, and Maya all incorporated planetary movements into their understanding of time and space, recognizing patterns that modern astronomy continues to study and predict. Tonight's conjunction offers more than visual spectacle. It provides insights into planetary motion, orbital mechanics, and our place within the solar system. As Venus and Mars appear to dance together in the sky, we're reminded that we're witnessing the same cosmic forces that shaped our understanding of the universe, from Kepler's laws of planetary motion to Newton's theory of universal gravitation. This celestial encounter sets the stage for exploring how these two dramatically different worlds continue to reveal secrets about planetary formation, atmospheric evolution, and the conditions necessary for life itself. Beneath Venus's brilliant exterior lies one of the most hostile environments in our solar system, a world that challenges our understanding of planetary evolution and atmospheric dynamics. The planet's dense atmosphere, composed of 96% carbon dioxide with traces of nitrogen and sulfur compounds, creates the most extreme greenhouse effect known to science. This atmospheric prison traps solar radiation with devastating efficiency. Sunlight penetrates the cloud layers, warming the surface, but infrared radiation cannot escape back to space. The result is a runaway greenhouse effect that maintains surface temperatures around 860 degrees Fahrenheit, hot enough to melt zinc and lead. This temperature remains constant across the entire planet, from poles to equator, dayside to nightside, creating a uniform hellscape unlike anywhere else in our solar system. The atmospheric pressure on Venus's surface equals that found 2,000 feet beneath Earth's oceans. This crushing environment would instantly flatten any unprotected human, while the atmospheric composition would prove immediately lethal. Sulfuric acid clouds drift 30 to 40 miles above the surface, creating a corrosive rain that never reaches the ground due to the intense heat below. These clouds completely obscure the surface in visible light, making Venus the most reflective planet in our solar system. Soviet and American space missions have provided our most detailed understanding of Venus's surface conditions. The Venera program, spanning from 1961 to 1984, achieved remarkable success in exploring this hostile world. Venera 7 became the first spacecraft to successfully land on another planet's surface in 1970, transmitting data for 23 minutes before succumbing to the extreme conditions. Later, Venera missions revealed a landscape dominated by volcanic plains, impact craters, and massive highland regions. Radar mapping by the Magellan spacecraft between 1990 and 1994 unveiled Venus's hidden surface in unprecedented detail. The mission discovered that over 80% of the planet consists of volcanic plains, suggesting massive resurfacing events in the planet's geological history. Mountain ranges stretch across continents larger than Australia, while impact craters appear remarkably well preserved due to the thick atmosphere's protection from smaller meteorites. Venus's slow retrograde rotation remains one of planetary science's enduring mysteries. The planet spins backwards compared to most other worlds, taking 243 Earth days to complete one rotation while orbiting the Sun every 225 days. This means a day on Venus lasts longer than its year, and the Sun rises in the west. Several theories attempt to explain this unusual motion, including massive impact events or gravitational interactions with other planets during the solar system's formation. The planet's lack of a magnetic field, despite its iron core, results from its extremely slow rotation. Without magnetic protection, Venus's upper atmosphere interacts directly with solar wind, causing atmospheric loss over geological time. However, the planet's massive atmosphere suggests ongoing replenishment, possibly through volcanic outgassing or other geological processes. Recent discoveries have renewed scientific interest in Venus's potential for past or present life. Phosphine detection in the upper atmosphere, though controversial, hints at possible biological processes occurring in the more temperate cloud layers 50 miles above the surface. These regions maintain temperatures around 0 degrees Fahrenheit and pressures similar to Earth's surface, conditions that could theoretically support extremophile organisms. Venus serves as a crucial laboratory for understanding climate change and atmospheric evolution. The planet likely began with Earth-like conditions, including possible oceans, before evolving into its current state. This transformation demonstrates how greenhouse gases can fundamentally alter a planet's climate, providing insights relevant to understanding Earth's own atmospheric dynamics and the potential consequences of unchecked greenhouse gas emissions. Mars presents a world caught between past and present, where ancient riverbeds carve through rust-colored landscapes and polar ice caps shimmer under alien skies. This fourth planet from the Sun offers tantalizing clues about water's role in planetary evolution and the conditions necessary for life beyond Earth. The red planet's distinctive color comes from iron oxide, commonly known as rust, coating much of its surface. This oxidation occurred over billions of years as iron-rich minerals reacted with oxygen in the planet's thin atmosphere. The process reveals a complex geological history involving water, atmospheric chemistry, and surface weathering on a planetary scale. Mars experiences dramatic seasonal changes due to its 25-degree axial tilt, similar to Earth's 23.5 degrees. However, The planet's elliptical orbit creates more extreme seasonal variations, particularly in the southern hemisphere. Summer temperatures can reach 70 degrees Fahrenheit near the equator, while winter brings temperatures plummeting to minus 195 degrees Fahrenheit at the poles. The planet's thin atmosphere, less than 1% of Earth's density, consists primarily of carbon dioxide with traces of nitrogen and argon. This tenuous envelope provides minimal protection from cosmic radiation and meteorite impacts, while creating dramatic temperature swings between day and night. Atmospheric pressure varies significantly with elevation and season, sometimes dropping low enough for liquid water to boil instantly at the surface. Evidence for ancient water activity appears throughout Mars's geological record. Orbital reconnaissance has identified dried riverbeds, lakebeds, and possible ocean shorelines, suggesting the planet once harbored substantial liquid water. The Curiosity rover's analysis of Martian rocks revealed clay minerals and chemical signatures consistent with long-term water interaction, indicating stable aqueous environments persisted for millions of years. Seasonal polar ice caps composed of water ice and frozen carbon dioxide expand and contract with Mars's orbital cycle. The northern polar cap, consisting primarily of water ice, contains enough frozen water to cover the entire planet in a layer 35 feet deep. This reservoir represents one of Mars's most accessible water sources for potential future human exploration. Recent discoveries have revolutionized our understanding of Mars's current activity. Recurring slope lineae, dark streaks that appear seasonally on crater walls and canyon slopes, suggest liquid water might still flow intermittently on the surface. Additionally, methane detection in the atmosphere hints at ongoing geological or possibly biological processes, as this gas breaks down rapidly under Martian conditions and requires continuous replenishment. The planet's geological features tell stories of violent upheaval and gradual change. Olympus Mons, standing 13.5 miles high, represents the largest volcano in the solar system, while Valles Marineris stretches 2,500 miles across the planet's surface, a canyon system that would span the entire United States. These features suggest Mars experienced significant volcanic activity and tectonic processes throughout its history. Mars's two small moons, Phobos and Deimos, likely represent captured asteroids orbiting close to the planet's surface. Phobos completes 3 orbits each Martian day, while gradually spiraling inward due to tidal forces. Scientists predict this moon will either crash into Mars or break apart into a ring system within 50 million years. Multiple space agencies currently operate rovers and orbiters, studying Mars's geology, atmosphere, and potential for life. The Perseverance rover searches for signs of ancient microbial life, while collecting samples for future return to Earth. These missions continue expanding our knowledge of Mars's evolution and its potential to support life, past or present, making it the most studied planet beyond Earth and our primary target for future human exploration. The apparent meeting of Venus and Mars in tonight's sky results from the intricate clockwork of orbital mechanics, a cosmic dance governed by the same physical laws that Johannes Kepler first described in the early 1600s. Understanding these celestial encounters requires examining how planetary orbits interact from Earth's unique vantage point as we journey around the Sun. Planetary conjunctions occur because each world travels its own elliptical path around the Sun at different speeds and distances. Venus, orbiting closest to the Sun among the 3 bodies involved, completes its journey in 225 Earth days. Mars, positioned farther out, requires 687 days to complete one orbit. Earth sits between these 2 worlds, circling the Sun every 365.25 days. These different orbital periods create a complex pattern of planetary positions. Venus regularly overtakes Earth in the inner solar system, approximately every 19 months, a period astronomers call the synodic period. Mars, moving more slowly in its outer orbit, experiences opposition with Earth roughly every 26 months when our planet passes between Mars and the Sun. The convergence of these cycles occasionally brings all 3 worlds into alignment from Earth's perspective. Tonight's conjunction represents a moment when Venus and Mars appear within a few degrees of each other in our sky, though they remain separated by over 100 million miles in actual space. This perspective effect resembles watching two aircraft at different altitudes that appear to fly close together when viewed from the ground, despite maintaining safe separation in three-dimensional space. The gravitational influence between Venus and Mars during conjunction remains minimal compared to the Sun's dominant pull. However, planetary positions do create subtle perturbations in orbital mechanics. These tiny influences, accumulating over millions of years, can gradually shift orbital parameters and contribute to the chaotic dynamics that characterize our solar system's long-term evolution. Ancient civilizations recognized conjunctions as significant events, incorporating them into calendars, navigation systems, and cultural practices. Babylonian astronomers meticulously recorded planetary positions, developing mathematical models that predicted future conjunctions with remarkable accuracy. These early scientists understood that celestial mechanics followed predictable patterns, laying groundwork for modern astronomy. Greek astronomers like Hipparchus and Ptolemy expanded upon Babylonian observations, creating geometric models that explained planetary motion. Although their Earth-centered model proved incorrect, their mathematical framework demonstrated how careful observation and logical reasoning could reveal underlying order in apparently chaotic celestial movements. The transition from geocentric to heliocentric models revolutionized our understanding of conjunctions. Nicholas Copernicus's 16th-century proposal that planets orbit the Sun simplified explanations for planetary motion, while Kepler's laws provided mathematical precision that accurately predicted planetary positions. Isaac Newton's theory of universal gravitation finally explained the physical forces driving these orbital mechanics. Modern astronomy uses conjunctions as natural laboratories for studying planetary properties. When planets appear close together, astronomers can compare their brightness, color, and spectral characteristics under similar observing conditions. These comparisons reveal information about atmospheric composition, surface properties, and reflective characteristics that might be difficult to determine from isolated observations. Space missions often time their trajectories to take advantage of planetary alignments. The Voyager missions famously exploited a rare alignment of outer planets in the 1970s and 80s, using gravitational assists to visit Jupiter, Saturn, Uranus, and Neptune with unprecedented efficiency. Similar principles apply to missions targeting Venus and Mars, where launch windows depend on optimal planetary positions. Tonight's conjunction also demonstrates the solar system's dynamic nature. Rather than static objects fixed in space, planets constantly move through complex gravitational interactions that create an ever-changing cosmic environment. These movements connect us to the fundamental forces shaping our solar system while providing spectacular displays that inspire continued exploration and discovery. As darkness falls tonight, Venus and Mars prepare to showcase one of nature's most elegant performances, visible to anyone with clear skies and a willingness to look up. This conjunction offers both seasoned astronomers and casual observers an opportunity to witness celestial mechanics in action, while connecting with the same cosmic rhythms that have inspired humanity throughout history. Venus will appear as the brighter of the two objects, shining with steady white light that easily outshines surrounding stars. Mars will display its characteristic reddish hue, appearing dimmer but distinctly colored compared to Venus's brilliant radiance. The two planets will appear closest together approximately 45 minutes after sunset, when the sky has darkened enough to reveal their positions while remaining bright enough to maintain visual reference points. No special equipment is required to enjoy this conjunction, though binoculars will enhance the viewing experience by revealing subtle color differences and allowing easier identification against the background star field. Telescopes can show Venus's current phase and Mars's tiny disk, though the planet's apparent proximity is best appreciated through naked-eye observation or wide-field binocular views. For those interested in photography, tonight's conjunction provides an excellent opportunity to capture planetary motion. A camera mounted on a tripod set to manual exposure mode, can record the planet's positions against the twilight sky. Exposures. 2 to 4 seconds at ISO 800 will typically capture both planets without overexposing Venus's brightness. Taking multiple photographs over several hours will document the apparent motion as Earth's rotation carries the conjunction across the sky. Weather conditions significantly impact conjunction visibility, with clear skies essential for optimal viewing. Light pollution, while not preventing observation of bright planets like Venus and Mars, can wash out the subtle beauty of their cosmic dance against the star field. Rural locations away from city lights provide the most spectacular viewing conditions, though suburban observers can still enjoy the event from their backyards. This conjunction represents just one moment in an ongoing series of planetary encounters. Venus and Mars will experience another close approach in 2026, while other planetary combinations create regular spectacles throughout the year. Jupiter and Saturn's great conjunction occurs approximately every 20 years, while the rarer alignment of multiple planets creates even more dramatic displays for patient observers. The scientific value of conjunction observations extends beyond their visual appeal. Amateur astronomers contribute valuable data through timing observations, brightness measurements, and photographic documentation. These citizen science efforts complement professional research while demonstrating how individual observers can participate in advancing our understanding of planetary motion and atmospheric properties. Tonight's event also connects us to the fundamental human experience of wonder and curiosity about our place in the universe. For thousands of generations, humans have looked up at the night sky and pondered the meaning of celestial movements. The same planets dancing overhead tonight guided ancient navigators, inspired mythological stories, and motivated the scientific revolution that continues expanding our cosmic perspective. As we observe Venus and Mars tonight, we're witnessing the same gravitational forces that shaped our solar system 4.5 billion years ago. These worlds formed from the same disk of dust and gas that created Earth, yet evolved along dramatically different paths that reveal the delicate balance of conditions necessary for life as we know it. The conjunction reminds us that we're passengers on spaceship Earth, traveling through a dynamic cosmic environment where planets, moons, and countless other objects perform an eternal ballet of motion and gravity. Each observation connects us more deeply to this larger cosmic story, while inspiring continued exploration of the worlds beyond our own. Tonight, as Venus and Mars appear to embrace in the cosmic darkness, we witness not just a beautiful alignment, but a demonstration of the physical laws governing our universe. This celestial dance continues the ancient human tradition of finding meaning and inspiration in the night sky, encouraging us to keep looking up and wondering about our place among the stars.